In this video, we are going to study about domain of logarithmic function. And for the domain of the logarithmic function and exponential function actually, but the exponential function part is not important for us because for all the exponential functions, the domain is going to be all real numbers. And here, for the, if you remember the form of exponential function, the base is going to be integer, or base is going to be number which is element of real numbers, positive real numbers, different than 1. In this case, the power, whatever it is, not important for us. The variable is going to be the power. Here 3 to the power of x is the example, and 5 to the power of x squared plus 2x. As you see, the power is x and x squared plus 2x. In both cases, instead of x, you can give any number that you want because it's not going to be undefined here. For the x values, you can give any number that you want. That's why we are writing for the domain of the exponential functions, always real numbers it's going to be. Only we have to be careful about the power. We have to be careful about the base. Base must be real positive number, different than 1. Okay, but we don't have the same easiness for the logarithmic, because for the logarithmic functions, what is written here as a gx must be greater than 0, or I am going to write gx must be greater than 0. Here, this part I am not using generally, and we are looking for when the function is greater than 0. What is written inside the logarithm? Here, x squared minus 4 there is, and it means that x squared minus 4 must be greater than 0, or x squared minus 2x minus 3 must be greater than 0. You know, ln is natural logarithm, which means ln is equal to logarithm base e it's going to be, and if you remember, e is equal to approximately 2.71. It's like pi, it continues till infinity. Okay, x squared minus 4 is greater than 0, x squared minus 2x minus 3 is greater than 0. These are both quadratic inequality, and we learned how to solve the quadratic inequalities. Only in the radical functions we were using greater or equal to sign here. Now we are going to use greater than sign. Okay, x squared minus 4 is the x squared minus 2 squared it's going to be. That's why it's going to be equal to x minus 2 times x plus 2. I have factorized this one. Then I'm going to find the critical points. When I say x minus 2 is equal to 0, x1 is equal to 2, this is the first critical point. And when I say x plus 2 is equal to 0, x2 is equal to minus 2, this is the second critical point is going to be. Okay, with respect to critical points, I'm going to draw the table. There are 2 critical points, so these lines are representing that the place of that critical points, minus 2 and 2. What about this one? This represents the minus infinity. This side is representing the plus infinity, if you remember. Then, the sign of the x squared is plus. That's why we are going to start with plus. So, when it is plus, you know that plus, minus, and plus it's going to be. Now, which areas I'm going to shade? Pluses or minuses? Or minus. Here, when it is greater than 0, it means that you are going to start shade the pluses. Okay, I shade the pluses. Now I'm going to use the integrals minus infinity till minus 2 union 2 to infinity. Again, I'm repeating this part. When you use infinity, the sides always must be open. You cannot use infinity with closed parentheses. Okay. Then minus 2 and 2 side. Minus 2 and 2 side is open because the sign is greater than sign. Okay, so this is the domain of the function. Also, it's written here. Here, the important part, real numbers except minus 2 and 2. When it says this is actually equal to minus infinity minus 2 union 2 to infinity. It must be. These are same sets, normally real numbers. Okay, what about the second one? X squared minus 2x minus 3. We are going to factorize x. Here it's going to be minus 3 and plus 1. Y minus 3 plus 1 because the sum is minus 2. And x minus 3 times x plus 1 is equal to, greater than 0. x1 is equal to 3 it's going to be, and x2 is equal to minus 1 it's going to be. I'm not explaining why x minus 3 is equal to 0, then x1 is equal to 3. I'm not explaining this part anymore. Okay, these are the critical points, minus 1 and 3. On the table, when we put the critical points here, minus 1 and 3 is going to be, then this is going to be plus, then minus and plus. You know that one, how to make plus, because the sign of the function is x squared. The main leading coefficient, actually, the leading coefficient is plus. That's why we are starting with plus, or the x times x plus x. That's why we are starting with plus. Now again, I'm checking for the greater than 0 or smaller than 0 part, greater than 0. So we are shading the pluses. Okay. Then the x is element of x such that is the element of x is element of minus infinity till minus 1 open union 3 to infinity is going to be our solution. Okay, if we continue with the another examples, x squared minus 3x minus 4 is the it was like the second exercise. X squared minus 3x minus 4 must be greater than 0. I'm going to factorize x and x. Here minus 4 and 1, it's going to be one of them minus 4. One of them must be minus 4 because minus sign, actually it should be, because the multiplication result is minus. Okay, then minus 4 times minus 3 it's equal to x minus 4 times x plus 1. It's going to be minus 4 times plus 1 is equal to minus 4. Minus 4 plus 1 is equal to minus 3. It must be. Okay, then is greater than 0. x1 is equal to 4 and x2 is equal to minus 1 is going to be. And with respect to these two critical points, here we are going to draw the table, and here minus 1 is on this side, plus 1 is on this side. Here it's going to be equal to plus, minus and plus. We are looking for greater than 0 part, so we are going to take always pluses. Pluses we are going to take, and in this side it was minus infinity, this side it was plus infinity, so the answer is minus infinity minus 1 union 4 to infinity. Infinity sides are always open parentheses. This is greater than 0, that's why it's open parenthesis again, and x such that x is an element of is going to be. Okay, this exercise, the next exercise, a bit different. Let me explain this one. X squared plus 1 is greater than 0. Why it's different? Because we cannot factorize this one. If you try, x squared plus 1 is equal to 0. This is x squared is equal to minus 1 is going to be. And in real numbers, we don't have solution for this system. But I know this one. X squared is always positive and 1 is always positive. So x squared plus 1 is always positive normally, which means domain of f is going to be all real numbers, because x squared plus 1 always positive it's going to be. If we are looking for x squared plus 1, x squared plus 1 is less than 0, I'm not going to write this part, I'm going to clean, and the solution set it's going to be empty. There's no solution is going to be, because x squared plus 1 always greater than 0, which means if we are looking for the smaller than 0, the answer is no solution. Okay, now we are going to find 12 minus x squared. If you have watched the quadratic inequality, I solved this kind of question. 12 minus x squared is equal to, 12 minus x squared is greater than 0 is going to be. And this is going to be in terms of a squared minus b squared form. A squared minus b squared, if you remember, a minus b times a plus b, and 12 is the square of 2 root 3 square. So the question is 2 root 3 square minus x square is going to be. Okay, what about 2 root 3? 2 root 3 squared minus x squared, it's going to be a squared minus b squared. 2 root 3 minus x times 2 root 3 plus x, it's going to be greater than 0. Then I'm going to find the x1. x1 is equal to 2 root 3 and x2 is equal to minus 2 root 3. It's going to be. Then I'm going to find the tables here. Table here. Minus 2 root 3 and 2 root 3. This side is infinity, this side is minus infinity. It's going to be. Now, plus or minus sign I'm going to decide about. Here, this sign, it should be minus. Why? Because the x squared coefficient is minus. That's why it should start with minus, then plus, then minus. It's going to be. Then we are looking for greater than 0. Here at this part, we are looking for, this is the greater than 0 part. Then the solution is minus 2 root 3 till 2 root 3. I didn't put the parentheses here. These are going to be open parentheses since the sign is greater than. Then 12 minus, x is element of x such that x is element of x such that x is element of is going to be, and here I'm going to write x in domain of the f. Domain of the function is x such that x is greater than minus 2 and 2 root 3 is going to be.